Example 7. From a committee of 12 people, in how many ways can we choose a chairperson, a vice chairperson, a secretary, and a treasurer, assuming that one person cannot hold more than one position? All right, so what's going on here is you have a committee of 12 people, and we're trying to put people in designated positions. Okay, so we need a chairperson, a vice chair, a secretary, and a treasurer. Okay, so there are 4 positions there. Okay, so out of the 12 people, we're putting them in groups of 4. Okay, again, is this a permutation or a combination? Okay, and again, you read at the very end, one person cannot hold more than one position. Okay, so there's no repetition. Okay, so let's think about this. Okay, I am again going to talk about those people I always bring up. So let's go back to Albert, and then Blanche, and then Carl, and Denise. Those are my buds. Okay, so let's say out of the 12 people, these were the 4 people on the committee who were going to hold the titles. Okay, so let's say Albert is the chairperson, Blanche is the vice chair. Vice chair. Carl is the secretary, and Denise is the treasurer. Okay, so if you're trying to figure out if this is a permutation or a combination, okay, switch the order and see if this makes a difference. Okay, so let's go ahead and change this up. Okay, let's change it so that the order goes Blanche, Denise, Albert, Carl. Okay, so what has this done? Well, now Blanche is the chairperson, Denise is the vice chairperson, Albert is the secretary, and Carl is the treasurer. So things have indeed changed. Okay, who's holding which position? That has changed from the first order. Okay, so changing the order matters, okay, because it changes who holds what position. Okay, so that makes this a permutation. Okay, so we are going to go ahead and set this up. Okay, we have our P, and we know we're choosing from 12 people, okay, and we're putting them in groups of 4, okay, because you're selecting 4 people at a time for the 4 positions, okay. So let's go to our calculator and figure this out. Okay, so I'm going to punch in 12, go to math, go over to probability, hit option 2 for permutation, and hit 4, okay. And again, there are 11,880 possibilities here. We've seen that number before. All right, so here we go. All right, so there are 11,880 different ways that we can choose a chairperson, a vice chairperson, a secretary, and a treasurer from this group of 12 people, assuming that one person cannot hold more than one position. Okay. Now, before we go on to part B, I want to mention something here. You may have read this problem and you may have immediately thought, hey, I want to do the blank thing. Okay, so like you said, okay, there's 4 positions that need to be filled. Just hang with me for a second. Okay, so as far as the blanks are concerned, we had to fill a chairperson, a vice chairperson, a secretary, and a treasurer. Okay, that may have been your first instinct. Well, let's see what happens if you thought this. Okay, so remember, there's 12 total people, okay, on this committee. Okay, so as far as the chairperson is concerned, okay, if we fill that first, okay, there's 12 people to choose from. Any of the 12 people can serve as the chairperson. Okay, once that position is filled, okay, person can't hold more than one office. So then there's 11 people to choose from to be vice chair. Okay, and then once those 2 positions are filled, you go on to the secretary. Okay, so can't choose from the person who's chairperson. You can't choose the person who's vice chair. So that leaves 10 people to be the secretary. Okay, and then finally, okay, you get to the treasurer, 3 of the spots are already occupied. You have 9 people remaining to choose from to be the treasurer. Okay, multiplication principle says that you would multiply these together. Let's see what happens. Okay, if I go to my calculator and I do 12 times 11 times 10 times 9, boom, you get the same number. Okay, so you may be wondering here, well, was I supposed to use a permutation or was I supposed to use the multiplication principle? And the answer is you could have done either. Okay, so here's something I haven't mentioned to you yet. I was waiting for kind of for you to get used to the idea of a permutation. Okay, permutations, or I'll just say a permutation, is a special instance of the multiplication principle. Okay, that's really important. Okay, what this is saying is that anytime you have a permutation, okay, you can either use the permutation formula or you can work it as if it were a multiplication principle problem, because every time you have a permutation is just a special instance of the multiplication principle. Okay, that's very important. Okay, now the flip of this is not true. Okay, there are some problems that you would use the multiplication principle on, but they're not permutations. Okay, and I'll make sure I'll show you one of those types of examples. Okay, so every permutation can be worked using the multiplication principle, but not every problem that you work using the multiplication principle is a permutation, if that makes sense. Okay, so regardless of whether you treated part A as a permutation or if you looked at it from the perspective of you have choices to fill and you use the multiplication principle, you should have come up with this 11,880 different ways to choose the chair, the vice chair, the secretary, and the treasurer. Okay. All right. So keep that in mind. Permutations can also be worked with multiplication principle. Important. Okay. Let's move on to part B. Part B is going to be a little bit different. We're not exactly assigning titles, okay? Hopefully you've realized from this problem and a couple of the other ones we worked so far, if you're assigning titles or positions, that makes it a permutation. The order matters because if you change the order, it changes who gets what title or what position. And so the order has an impact and that makes it a permutation. If you look at the question in B, so we're still working with the original committee of 12 people, but now we want to form a subcommittee. Okay, so in how many ways can we choose a subcommittee of 4 people? Okay, so in part A, you were also choosing 4 people, but you were assigning them titles. Like so-and-so has to be the chair, so-and-so has to be the vice chair, somebody else is the secretary, and then this other person is going to be the treasurer. But in part B, we're choosing a group of 4 people from the group of 12 people from the overall committee, and we're not assigning titles. Okay, so it's a little bit of a different thing here because you're not assigning titles. Okay, so we're making a subcommittee, so that's just a smaller committee of the larger committee. Okay, so again, let's take my buddies, Albert, Blanche, Carl, and Denise, okay, and say, out of the 12 people, these are the 4 people I picked for the subcommittee, okay? Let's change the order and see if there is an impact, okay? So if I change my order to Blanche, Denise, Albert, and Carl, okay, guess what? That's still the same subcommittee, okay? Changing the order doesn't change the people, the 4 people who are on the subcommittee, okay? So this is a combination because order does not matter here. If you take 4 people and change the order that those 4 people are written in, you still have the same subcommittee, okay? So this is going to be a combination, okay? We're picking from the entire group of 12 people on the original committee, and we're picking them in groups of 4 to form a subcommittee. Okay, so let's go to our calculator here, and we're going to do 12 go to math, go over to probability, hit option 3 to do a combination, and we're putting them in groups of 4, okay? So remember, how should this number compare to the permutation of 12 things taken 4 at a time? You're going to get a lot less combinations because order does not matter. Okay, so watch, when we pop this out, we're going to get only 495. Okay, so this is going to be 495 different possible subcommittees. All right, so what you should be gathering from parts A and B is that if you have some group of people and you're trying to assign titles or positions or rankings to those people, that makes it a permutation. But if you're not doing that, if you're just forming a smaller group of people from the larger group and you're not having anyone hold a title or a ranking, then that is a combination. Okay. Let's move on to part C. There's a little bit of, that's going to throw another little twist into this type of problem. All right, so here we go, at the top of page 5 here, okay? It says, in how many ways can we choose a subcommittee of 4 people if either Michael or Maisie, but not both, must be on the committee? All right, so this is a tricky one. So read it again and again to make sure you understand what this is asking. Okay, I'm going to read it again. And how many ways can we choose a subcommittee of 4 people if either Michael or Maisie, but not both, must be on the committee? Okay, so here we are, same kind of setup. We have an overall committee of 12 people. We're forming a subcommittee that consists of 4 people, but now we have this requirement that either Michael or Maisie has to be on the committee, but both cannot be, okay? Also to note, we are not assigning titles here, okay? So because we are not assigning titles, okay, it is not a permutation. And it does involve the subcommittee. Okay, so you're forming a smaller committee or a smaller group from the larger group. So there is going to be a combination involved, but you've got this strange twist about Michael or Maisie. Okay, so let me show you how you're going to do this problem. Okay, we're going to use blanks. Okay, so I'm going to form my first blank. Okay, the strange requirement is that Michael or Maisie has to be on this committee, but not both. Okay, so we need to fill in that blank. Okay, and then we're going to have another blank for the remaining 3 people on the committee. Okay, because remember, your subcommittee is going to have only 4 people. Okay, you've got to make sure everybody is accounted for. Okay, all right, so let's talk here. Let's go to the first blank. Okay, Michael or Maisie. Okay, how many possible choices are there for this? Okay, well, either Michael or Maisie. Okay, so there's 2 choices here. Okay, the first person on the committee has to be either Michael or Maisie. Okay, not both, but there's 2 choices there. Okay, remember, you fill in the blank with the number of choices. Okay, either Michael or Maisie. So there's 2 choices for the first person on the committee. Okay, then we're going to go to the next blank, which is going to handle the remaining 3 people that have to be on the committee, okay, or the subcommittee. Okay, so remember, you're going to the overall group now. Okay, so let's say the overall committee, remember how it was formed. We don't know specific names, but we know Michael is in the original committee. So is Maisie. Okay, and then we have these 10 other people. So I'm just calling them with numbers here because I don't know their names. Okay, so those that's the original 12. Okay, so I'll even put that here. Okay, so the original 12 people, okay? So we know it's Michael and Maisie and then 12 other, or sorry, Michael and Maisie and then 10 other people, okay? So what's happening now, okay, the first position on this subcommittee is going to go to Michael or Maisie, one of them, but not both, okay? So we've already handled them, so I'm going to scratch them out. So there are 10 people remaining from which to pick the 3 people on the subcommittee, okay, the 3 positions that are left, okay? So order's not going to matter here, okay, because if you put these 3 people in any order, it's still the same 3 people on the subcommittee, okay? So it's going to be a combination, okay? You're going to be choosing from 10 people, not 12. It's the 10 people remaining on the large committee, taking away Michael and Maisie, okay? So out of the 10 people, you're choosing 3 of them to be on the subcommittee, okay? So this is how you would set this up, okay? Because you've got blanks, okay, this is overall a multiplication principle problem. So we're going to multiply this together. So this is going to be 2 times, we need to go to the calculator and figure out 10 choose 3. Okay, so let's do that. So let's do 10 math, go over to probability. We're going to do option 3 for a combination, and we're going to choose 3. Okay, so that's going to give us 120. Okay, so if we go over here and we do 2 times 120, okay, there's going to be 240 possible subcommittees. Okay, does this make sense? Well, okay, remember in part B, we had to find the total number of subcommittees, okay? If we had 12 people to choose from and we put them in subcommittees of 4 people, what was the total number of subcommittees that could be formed among 4 people, okay? And remember, we got 495 different possible subcommittees. So if we put this extra condition on there that Michael or Maisie has to be on the committee, but not both, it really should narrow this 495 down, okay? And it did, okay? Because now there's only 240 possible subcommittees, okay? So this was a tough problem, okay? Again, you should be realizing that if you're taking people and putting them, assigning them some kind of rank or title, should be a permutation, okay? If you're just taking a group of people and putting them into smaller groups without any kind of rank or title, then it becomes just a combination, okay? And then if you have a strange requirement like this Michael or Maisie condition, okay, sometimes you're going to have to involve your problem is going to involve both the multiplication principle and a permutation or a combination, okay? So you have to watch out for that. We're going to do more practice with problems like this where you're having kind of a mixture of the multiplication principle and a combination or a permutation.